Today we begin exponential functions. You may have had these in Algebra 1. Exponential functions is a function where the x is in the exponent. The x is in the exponent. So this is what a parent function of an exponential function looks like. B is called our base, and it's important to note that the base is always positive, and it's never 1. And then, it's obviously not a 0 in front. So the basic one that we use for our exponential function is y equals 2 to the x. And anytime we have a new function, we always can make a quick chart to show, right? And let's give some negative numbers, 0, and some positive numbers. If I start with the positive numbers, 2 squared is 4, 2 to the first is, 2, 2 to the 0 is 1, 2 to the negative 1, 1/2, and 2 to the negative 2, 1/4, right? So 1/2, 1/4, doesn't want to write. And then if I graph those, you'll see the basic shape of the exponential function. There's 1/2, there's 1/4. So 0, 1 is kind of our big point that I'm going to use for moving the graph up and down and right and left. So the graph looks like this. So what we notice is that this graph has, our old friend, a horizontal asymptote. So I know I didn't ask this here, but I'm just going to write that it has a horizontal asymptote at y equals 0. And then if I did the domain and the range, what would the domain be? Right, all real numbers. It doesn't matter what the exponent is. And what about the range? Right, it's always greater than 0. Right, anytime you have a positive number raised to any power is always positive. 1/2 to the x, I'd like to point out, is the same as 2 to the negative x. 1/2 to the x is the same as 2 to the negative x. Why? Right, because 1/2 is the same thing as 2 to the negative 1. And if I do a little chart for this one, right, 1/2 to the negative 2 power, think about that for a second, but that's 4 and 2 and 1 and 1/2 and 1/4. So this graph looks like this. And that should make sense because if we think of it as 2 to the negative x compared to the parent graph, it's going to reflect over the y-axis, and that's what happens. This first graph we're going to call eventually exponential growth, a graph that's growing. Exponential growth. And then do you know what the second graph is going to be called? Exponential decay, right? Exponential growth, exponential decay. Perfect. So the first ones are kind of like shifting this graph around. So I take the parent graph here and I'm going to go right 2 down 1. So I'm going to usually shift like that ordered pair 0, 1. I'm going to shift that right 2 down 1, and then my asymptote is always like 1 below that, right? So it looks like this. The domain is always all real numbers. Here it's y is greater than negative 1 with a horizontal asymptote at negative 1. When I'll multiply on the outside by a negative, do you remember what that reflects over? That reflects over the x-axis, right? So my original graph was there, so now my new graph is going to be like here, like that. So here the domain is still all real numbers, but now the range is less than 0, but it still has a horizontal asymptote at 0. 2 to the negative x is the one that we just did, and it can be like a general graph, like as usually as long as I have that 0, 1 point in there, I can be kind of good with that, greater than 0, horizontal asymptote at 0. And then negative 2 to the negative x, this is going to reflect over the x and over the y. This turns out to be like this. So this is all real numbers again. Y is less than 0 and y equals 0. Okay, now we're going to solve exponential equations by writing both sides as powers of the same base. So here I see 3 to the 5th, 3 to the 2n minus 1. Since these are both the same base, I can set the 5 equal to the 2n minus 1. So 6 equals 2n, so n equals 3. But I can't do that in number 6 because they're not powers of the same base. So I got to rewrite 9 as 3 squared and 27 as 3 cubed. And remember, when I raise a power to a power, I multiply the exponents. Now I've got them the same. So now I can set these two powers equal. So 3x is negative 6, so x is negative 2. It could be a little tricky for people to write 1/16 as a power of 2. Do you know what that is? 2 to the? Right, negative 4. So x plus 3 equals negative 4, so x is negative 7. And then the last one, 49, is obviously 7 squared, but how can I write square root of 7 as a power of 7? Right, it's 7 to the 1/2 power to the 2x minus 4. So I get 7 to the 6x equals 7 to the x minus 2. So 6x equals x minus 2, so 5x equals negative 2. So x is negative 2/5. So yeah, that's it. So that is our graphs of exponential functions and early solving of exponential equations.